Your server is in Virginia. Your user is in Tokyo. That's 11,000 kilometers of internet infrastructure between them. Every single request, every image, every style sheet, every JavaScript bundle, traveling halfway around the world and back. That's not a code problem, that's a distance problem. Network hops, routing, and yes, the physical limits of how fast data travels. You can't optimize your way out of speed of light, but you can move the data closer. That's what a CDN does. CDN stands for Content Delivery Network. What is it? You have your origin server, that's where your actual application lives. A CDN adds edge servers distributed across dozens or hundreds of locations worldwide. These are called points of presence, or POPs. When a user requests content, the CDN routes them to the nearest edge server. If that server has the content cached, it responds directly. The user never hits your origin. If it's a cache miss, the edge server fetches from your origin, serves the user, and caches the response for next time. Now every subsequent user in that region gets the fast path. To put it in a few words, a CDN trades storage at the edge for reduced latency and origin load. Not everything belongs on a CDN. One question determines the path. Is this content the same for every user? A product image? Identical for everyone. It takes the edge path, served in milliseconds from a server nearby. A shopping cart? That's your cart, not mine. It has to go to the origin every time, no shortcut. Static assets, images, style sheets, JavaScript bundles, fonts, videos, these are edge path all day. Cache them aggressively. But not everything is binary. Some API responses can be cached. Weather data? Same for everyone in a city. Cache it for about 5 minutes. Product catalog? Cache it for an hour. The point is to recognize what's truly personal versus what just feels dynamic. Your origin server controls CDN behavior through HTTP headers, specifically cache control. Breaking it down, public means any cache can store this. CDN edges, browser caches, proxies along the way. Use this for static assets. Max age of 31,536,000 is the TTL, time to live, in seconds. This is 1 year. The CDN will serve this from cache for a full year without checking your origin. Private means only the user's browser can cache it, not the CDN. Use this for personalized content. No store means don't cache anywhere ever. Sensitive data, session-specific responses. One common pattern, content hashed file names. The hash changes when the file changes, so the URL itself is different. You can set max age to a year because you'll never need to invalidate. You're just requesting a new URL. Same traffic, 2 setups. Without a CDN, every request, no matter where it originates, hits your origin. Launch day traffic, marketing campaign goes viral, your single server takes the full impact. With a CDN, for a site that's mostly static content, cache hit ratios typically range from 60 to 95%, depending on your content mix. The more static your assets, the higher that number. Your origin only handles the genuinely dynamic stuff. That's origin offloading. Fewer servers, lower costs, and your origin stays responsive for the requests that actually need it. And when malicious traffic hits, a DDoS attack on a single server can take you down. That same attack spread across 100 edge locations, each server handles a fraction. Most CDN providers include DDoS mitigation as a core feature. It's a natural side effect of distributed architecture. CDNs aren't a perfect solution. They're a set of trade-offs you control. Trade-off 1, cache invalidation. You fix a critical bug, you deploy to origin, but your JavaScript is cached at 200 edge locations for the next 6 hours. Now what? Think of it like running a library system with 200 branches. You find an error in a popular book and print a corrected version. Now you need every branch to pull the old copy from their shelves. Some branches are closed for the night, some already lent the book out. Coordinating that across 200 locations? That's cache invalidation. CDNs offer purge APIs, but it takes time to propagate globally. This is exactly why the hashed file name strategy works so well. When the file changes, the file name changes. No invalidation needed. Trade-off 2, cost. CDN pricing scales with bandwidth. High-traffic sites often save money overall by reducing origin infrastructure, but you're trading one line item for another. Do the math for your traffic patterns. Trade-off 3, personalization. If every user sees completely different content, you'd be caching millions of variants, which defeats the purpose. Edge caching works best when many users share the same content. To recap, this is how a CDN works. Request comes in. First gate, is this content cacheable? Same for everyone or at least for a group. Second gate, is it already in the edge cache? If yes, fast path. If no, fetch from origin, cache it, serve it. And that's it. A CDN is caching, distributed globally. Same invalidation trade-offs, same TTL decisions, just spread across the planet. CDNs turn a distance problem into an infrastructure solution. Know what to cache, configure your headers correctly, and have a plan for when you need to invalidate. If this helped, drop a like. Thanks for watching, and see you in the next one.